Let us continue the last session. We are discussing a sample context-free grammar. So here, just we'll see the derivation part of this context-free grammar. A derivation is a sequence of rule applications that derive a terminal string from start symbol. That is something like this. So if you take an example of a particular start symbol or sentence will be followed by noun phrase and verb phrase, and this can be further derivated as proverb and verb phrase, and here this proverb is I and then verb phrase, and again verb phrase is converted as verb and noun. Here then that verb may be prefer, then we still have a noun phrase. In this noun phrase again we can divide this noun phrase as a determinant and nominal. So that determinant may be, I already told you, it is like a and the, that, this, so it will be a, and then noun, and again this nominal can be a nominal and noun can be a noun and noun. That is, I prefer a morning, again noun is a flight. Means if you take a particular sentence, okay, first we need to define first a particular sentence, and if it follows then we are going to derive in a particular format as per the context free grammar. And see here the same thing how we are going to have, this is called as a parse tree. So a sample phrase structure tree, or we can also call it as a parse tree. So sentence, noun phrase, verb phrase, noun can be pronoun and verb can be verb and noun. That verb leads to the sentence, okay, that particular keyword. Noun can be determinant and nominal can be noun, nominal can be noun, and noun will be flight. In this way, I prefer a morning flight. If you take an example, the way how we are going to derive the sentence is this one, and the structure of the particular tree will be something like this. Now next, context free grammar is the same. So here we can see the start symbol is the root, and these which we have derived one particular sentence is called as the leaves, that is bottom. So this is root or top, and these are called as the leaves or bottom. So parsing with, let us see with the context free grammar. Parsing is the process of taking a string and a grammar and returning the parse tree for that particular string is called as this parsing. Okay, we are going to take a string and we are going to take a grammar, and returning the parsing tree of the particular string is called as this parsing. And parsing with CFGs refers to the task of assigning proper trees to the input string. So here proper means nothing but a tree that covers all and only the elements of the input and as an yes at the top. Yes, starting symbol with yes followed by all the and only the elements of the input, generally we call it as the parsing should be proper. And how to parse? There are two ways to do this parsing. One is the top down and other one is the bottom up. So start at the top of the tree with an yes node and work your way down to the words is called as the top down words. Top down parsing. That is, we are going to start with the start symbol and at last we reach to the words, that is called as top down. And bottom up is look for the small pieces that you know how to assemble and work your way up to a larger pieces. That is, we call it as the bottom up parsing. So these are the two parsing techniques in this context free grammar parsing. And see here, top down search builds from the root yes node to the leaves. Why? Because it is top down, expectation based, and common top down search strategy how it will be is top down left to right with backtracking. Okay, top down left to right and with backtracking is the way how we do this top down parsing. And try first rule, that is LHS is compulsory start symbol. Next, expand all constituents on RHS and iterate until all leaves are parts of speech. And backtrack when candidate parts of speech does not match the parts of speech of the current word in the input string. Okay, so when parts of speech does not match with the current word, again we need to backtrack and until this particular candidate parts of speech is going to match with the current parts of speech. So this is the procedure how we are going to follow in the top down search. Next, bottom up parsing. The basic idea is starting with the leaves, means down we are going to start and we are going to build the tree by matching the right hand side of the rules. Generally here right hand side rules we are going to try to match and we go to the top of that. And build a tree with S at the root. Starting from the words we are going to build at the tree with the S as the root. See here. So this is bottom up parsing. We started with the book, that, flight, verb, determinant, noun, and that noun can be nominal. That nominal and determinant combinedly gives the noun phrase, and this verb is verb phrase, and this verb phrase is nothing but the sentence. So in this way we are going to determine how we are going to build this bottom up search tree. Next concept is introduction to the automatic speech recognition, or simply we call it as the ASR. So what is this ASR? This automatic speech recognition or speech to text, simply we call it as STT, is a field of study that aims to transform raw audio, what we speak, into a sequence of corresponding words. So generally some of the speech related tasks involves speaker diarization, that is the process of partitioning an audio stream containing human speech into homogeneous segments according to the identity of each speaker, that is which speaker spoke when. That is what we call it as a speaker diarization. And speaker recognition, that is who spoke. And spoken language understanding, that is what is the meaning of that particular language spoken by a speaker. Then sentimental analysis, how does the speaker feel. These are all some of the tasks involved for this automatic speech recognition. And then this is the classical pipeline in an automatic speech recognition, which involves when your speaker is speaking something, this automatic speech recognition, that is ASR, is given to a natural language processing, and it is also given to a text to speech synthesis, and then we are going to get the output. So this is the pipeline of an automatic speech recognition. Let us see the key features of effective speech recognition. Many speech recognition applications and devices are available nowadays, but the more advanced solutions are use AI and ML. And they integrate grammar, syntax, structure and composition of audio and video signals to understand and process the human speech. Yes, to understand and process the human speech, we require all these things. We have to integrate the grammar, syntax and structure and the composition of both audio and the voice signals. And then language weighting, we are going to improve precision by weighting some specific words which are spoken frequently, such as product names or industry jargon, whatever it may be. Beyond terms already in the base vocabulary, we have to give some weightage to some of the terms. Then speaker labeling. Output is transcription that cites or tags each speaker's contribution to a multi-participant conversation. And other feature is acoustics training, that is attend to the acoustical side of the business. Train the system, we are going to train the system to adapt to an acoustic environment like the ambient noise in a call center and speaker styles like voice, pitch, volume and pace. These are all comes under some acoustics training. Then profanity filtering. This we know that profanity filtering, profane means use filters to identify certain words or phrases and sanitize the speech output. Some unparliamentary words if someone is using, and if you want to filter that, so compulsory we have to make use of this profanity filtering. And then how this automatic speech recognition works. Let us see this. The basic sequence of events that makes any ASR software, regardless of its sophistication, pick up and break down your words for analysis and responses goes as follows. First, we speak to the software via an audio feed. This is the very first step. The device we are speaking to create a wave file of your words. Okay, then the wave file is cleaned by removing the background noise, and this normalize the volume. If it is high or low, it is going to normalize the volume. The resulting filtered waveform is then broken down into what are called as the phonemes. Okay. Generally, these phonemes are the basic building block sounds of language and words, and in English we have 44 of them, these phonemes, which consists of like sounding blocks such as WH, TH, KA and T. These are the some of the phonemes. With the help of these phonemes, whatever the broken down of that particular voice, at last it is going to group them into a final sentence. See, each phoneme is like a chain link. And by analyzing them in sequence, starting from the first phoneme, the ASR software uses statistical probability analysis to deduce the whole words and then from there complete the sentences. That is what. Okay. Now now our ASR having understood our words and respond to you in a meaningful way. What we spoke now, then it is going to understand and accordingly it will be respond. So here you see how our devices learn to talk to you. This is how ASR, automatic speech recognition, works. You speak into a device like what is the forecast. Then the second step is the device creates a waveform from the sound. Okay, and background noise is reduced and the volume is normalized. That is the third step. And coming to the next fourth step, that filtered waveform is broken into phonemes. Here you can see the one of the phoneme as WH. These phonemes are the sounds used to build words, and English language has 44, French has 33 and Italian has 49. These are the phonemes. With the help of only this, at last we are going to form a sentence. Then each phoneme is like a link in a chain, and based on the first phoneme, statistical analysis is used to find the most likely phonemes to follow. See here, what, here WH, then A, then T. Okay. Next, words are connected in the same way, like what's the weather forecast. Okay, something it will respond like 72 and it is sunny. So in this way, how this automatic speech recognition works. And the examples of this ASR is, we know that one is the directed dialogue conversation, and another one is a natural language conversation like chatbots. So if you ask like which of the following would like to do, check my balance, make a payment, change my account, or more options, then check my balance someone is asking, then your balance is. So this is called as if you have such a conversation, then we call it as a directed dialogue conversation. And natural language conversation, it is something like ask how can I help you, what's the weathercast, then it is going to respond. So ASR can be used in different ways, but two examples we probably experiences are these two, directed dialogue and the natural language conversation, which we'll choose from a set menu of choices. And whereas in natural language we'll have an open-ended conversations directly with the person. And there will be two more important concepts like tuning test, how ASR is made to learn from humans, and other one is the active learning. So this training of ASR systems be the NLP or directed dialogue systems works on two main mechanisms. One is the simpler is human tuning, and the second much more advanced variant is the active learning. So what is going to be done in human tuning? This is a relatively simple means of performing ASR training, that is it involves human programmers going through the conversation logs of a given ASR software interface and looking at the commonly used words that it has to hear, but which does not have its own pre-programmed vocabulary. So these words are then added to the software so that it can expand its comprehension of the speech. So nothing will be written. Accordingly, whenever we talk something, that software, okay, there will be it involves some programmers, and along they are going to interact with the ASR software interface and looking at the commonly used words. This is how this human tuning works. And the second one is the active learning, is a much more sophisticated variant of ASR and is particularly being tried with NLP versions of speech recognition technology. And here this active learning, the software itself is programmed to autonomously learn, retain and adapt to the new words, and thus constantly expanding its vocabulary as it's exposed to new ways of speaking and saying things. So these are the two things. So this is how one is tuning. Here you can say that I always learn so much from our conversations, and here this is active learning. So if you say something, then see here, I will call you an ambulance. No, I mean call an ambulance for me. So it's simply it is going to call for the ambulance. Okay, how we will talk something in a phone and it is going to give us the response. So these are the two ways tuning test of this ASR, that is tuning and the active learning. So this is all about this automatic speech recognition.